So I want to give you a summary of this course and wrap it up in maybe a nice way to remember. Let X be a set. So we can define these things like logical statements on X, and these are just functions so we have the set of logical statements on X, and this is just functions from X to the set of true and false. And we have the power set of X, which is the set of all subsets of X. So this is the power set. And we showed there's a bijection between these sets, and we also said these sets had some operations on them. So this was and, or, not. Here was intersection, union, and complement. And this bijection corresponds these operations as well. So and or not corresponds to intersection, union, and complement. So they correspond on this bijection. The bijection was simply defined to be, it takes a function B and takes it to the pre-image of true under B. And the subset U goes to the characteristic function of U, so the function that sends U to true and everything else to false. Okay, so we had logical statements defined as functions on a set, and we can make the set of all such logical statements. Then we have sets, which we've made as a set of subsets of a fixed set. Okay, and then we said that sets have structures of intersection, union, and complement. The set of logical statements have a structure of and, or not. And then there's a bijection between these two sets that preserves these operations. So that's a nice way of summarizing everything we've done in sort of one go. Because to understand this, you'll need to know what all these things mean. And if you want to adopt the language of that extra credit exercise, then another way of saying this is that this set of subsets together with these operations is the Boolean algebra of algebra. This is the Boolean algebra, the power set. Or the power set is a Boolean algebra. And taking this set of logical statements and these operations makes a set of logical statements a Boolean algebra. So set of logical statements together with and, or, not, and yes, we should also add that the empty set here corresponds to the false statement, and the whole set corresponds to the true statement. So that the false statement is the function that takes everything to false, and the true statement is the function that takes everything to true. So logical statements together with these things and the false and true statements is a Boolean algebra. The power set with these operations and the distinguished elements of the empty set and the whole set is also a Boolean algebra. And then the bijection that we have becomes an isomorphism of Boolean algebras. Okay, so that's a nice way to summarize the contents of this material. But to fully have gotten everything out of this class, you have to be able to not just know this, but have the mental aptitude to use and deal with concepts of similar difficulty.